And welcome back to another geography episode. Today we're going to look at a map book paper and we're going to revise an old question paper. Now what I want you to do is to pay attention particularly to the map that's been given to you, because most of the time all the references, everything is in front of you to be able to answer the questions. But let's get straight into it. Your first question usually consists of short answer questions, multiple choice. And what you need to do is you need to use your topographical map, that's a 1 to 50,000 map, as well as your orthophoto, the 1 to 10,000 map. Now let's just quickly have a look at a few of the questions. Now the contour interval of the topographical map is, now very importantly, what is contours? Contours are lines joining places with equal altitude. Now you get this information on your map. Now if you quickly go to the Messina map, there you can see over there the contour interval on a topographical map is 20 meters. So there's your first answer. All you need to go and do is go and look at your references. The correct answer is number D. Okay. Now if you look at the next question, the height of the N1 national route at 2 in block F1. Okay, let's quickly go and have a look. Now first of all, how do we determine what is the N1? Once again, you need to go to your references, and there you can see it's a national route. It will be blue in color or it will be red in color. All you need to do is go to your references. So the question states in block F1. Now let's quickly find block F1 and number 2. So there's it. So the question states, what is the height of the N1 over there? Now it's quite easy. You look at the spot height, it's 521, and you go to your closest contour line and you will see your closest contour line, the height represents 520. And there's your correct answer. Now remember, contours represents altitude. It's lines joining places of equal altitude. Our next question, the settlement of Arton Villa in F6 originally developed as what type of settlement? Now let's quickly have a look at F6. See how easy it is when I use my map to find information. Okay, there's F1, F2, F3, F4, F5. Okay, there's it. Now as you can see, Spence Shaft, a disused mine. Now that is a clue to determine, and it gives us, let's see if they give us the option of mining, and yes, it's number A, mining used to take place over there. Now the feature number 3 in block H2 is let's quickly go and have a look at H2. Now there's the feature number 3. Now what is it? If you don't know what it is, once again, go to your references to find the answer. It looks like a W, and as you can see, am I right if I see it over there? It's this reference, this key over there, and that represents a communication tower. And let's see if they give you the option of a communication tower in your multiple choice. Yes, they do. And there is your correct answer. Quite simple, isn't it? You just need to go and look for the correct answer. Now the word scale of the orthophoto map is what? 1 centimeters represents 10,000 meters, 1 centimeters represents 100 meters, or 1 centimeters represents 100 meters. In this case, the correct answer will be number C. Okay. Now, if we look at question 1.6, the slope between L and M in an orthophoto map. Let's quickly go at the slope between L and M. The slope between L and M situated over there. Now, as you can see, the first thing that I pick up from this image over here, look how far the contour lines are from one another. So do you agree with me? Remember, when contour lines are very far from one another, it's a gentle slope. When the contour lines are close to one another, It's a steep slope because these contour lines represents altitude. So it means from the one contour line to another contour line, there's an interval. For instance, on orthophoto is usually 5 meters. On topographical map, it's 20 meters. So I will definitely say, if you look between M and L, look how far the contour spacings are. It's definitely a gentle slope. Let's see if they give us the option over there. Yes, C, it's definitely a gentle slope. The direction of land use from land use K on the orthophoto map is the direction of land use J from land use K. So you need to determine from K to J. Don't get confused. Look at the keyword over there. Now let's quickly go and have a look at the orthophoto map. So the direction of land use J, land use K, there's K, and let's see where's J. What is it? It will be from K to J will be northwest. Remember, there's north, east, south, west. It's in a northwest direction. Let's see if they give us the option. Yes, they do. It's north, northwest. Let's just quickly go back to it just to determine the correct direction. There's K, there's J. It's north, northwest. Northwest will be more into that direction over there. Remember, when you determine your direction, draw a north-south line and draw a line from where and to, and determine it by using your 16 cardinal points. If you look at question 1.8, the refuse dump at N on the orthophoto is mainly used for what type of waste? Now let's quickly go and have a look at the refuse dump at N. Now there's N over there, the refuse dump. If you can see over there, there's the industrial area. So I reckon the waste that's being disposed over there is for this industrial area over here. So the correct answer will be A. If you look at question 1.9, the residential area marked G in the orthophoto map shows a rough what type of street pattern. Now let's quickly go and have a look at that, at number G. Now this is definitely not a gridiron pattern. It's definitely not a radial pattern. So the correct answer will be, it's definitely planned because you can see the stand sizes and there's a lot of vegetation around it and recreation areas of it. So it's planned irregular. Let's see if they give us the option. Yes, they do. D will be the correct answer. Okay, so that's our multiple choice questions. Let's quickly move on to question 2. And that's our calculations that we need to do. Now calculate the area of the rifle range E on the orthophoto map in square kilometers. Show all calculations. Now remember, there's your key. Square kilometers and orthophoto map, because we use a different formula for orthophotos comparison to the topographical map. Now let's just quickly find this rifle range. Now first of all, before we find the rifle range, what's the formula for area? Area equals length times breadth. Okay, now let's quickly go and find the rifle range E. There's your rifle range that they ask you to go and calculate the area. So what you need to do is, remember, to be able to do your calculations, you need your calculator, you need a protractor, and you need your ruler. And we're going to use both of these instruments right now, your calculator and your ruler. So first of all, there you got E. So what you need to do is, you go and measure your length. And the length that we get on the orthophoto is 10 centimeters. So 10 centimeters. Now what is the formula on an orthophoto map? To convert to kilometers, we use 0,1. If we want our answers in meters, we times it with 100. In this case, we want to answer in square kilometers. So it's 10 centimeters times 0,1. Now we need to go and measure the breadth. Look at it. So you take your ruler, you place it, see how wide it is, and the correct measurement that we get is 1,3 centimeters. And same, we need to convert it to kilometers, 0,1. Now use your calculator. It's 10 times 0.1. That equals 1 times 1.3 centimeters times 0,1, and that gives us 0,13. Now we need to calculate our final result between the two of them, and use your calculator once again. 1 times 0,13, and you get your answer is 0,13 square kilometers. Remember your square kilometers, or else you're going to be penalized with a mark. Now, question 2.2. Determine the present magnetic bearing. Now, keep in mind, it's not magnetic declination, it's magnetic bearing. From trig station 17 in G1 to Spain's shaft F5. Now, what's the most important over here? Stick to your formulas. Now, once again, we've got a formula over here. Magnetic bearing equals magnetic declination plus true bearing. Now, first of all, let's go and calculate our magnetic declination for the map of Messina. And where do we find this information? On a topographical map. And as you can see, the mean magnetic declination was 12 degrees, 57 minutes, 2002. Every single year has changed 7 minutes west. Forget about the dates of 2000, 2005. So let's go and calculate our present magnetic declination. Now the magnetic declination for the Messina map is 12 degrees, 57 minutes. Magnetic declination is 12 degrees, 57 minutes. And the map was drawn, let's just quickly go back, in 2002. Now the annual change, the yearly change, was 7 minutes west. And we know if we move west, what do? We add. Remember that. West we add, east we subtract. Now we need to go and calculate the present magnetic declination. And the present year is 2017, subtracting 2012, and that equals 2002. That gives me 15. Now, from 2002 to 2017, there's a 15-year difference. Every single year, it moved 7 minutes west. So what do we need to say? 15 times 7 equals, let's quickly go and calculate that. 15 times 7 equals 105. Now 105 minutes. Now remember, just want to write in a different color pen, 1 degree equals 60 minutes. So let's say 105 subtracting 60 minutes. 105 minutes subtracting 60 minutes, that gives us 45 minutes. So basically, this equals 1 degree and 45 minutes. 105 minutes equal 1 degree and 45 minutes. And because we're moving west, what do? We add it up. 12 degrees, that's where I get it from, 57 minutes plus 1 degree, 45 minutes. Because we're moving west, we are adding. Okay, So let's quickly have a look at it. Now we got 57 minutes and 45 minutes. Let's just quickly add those two together. 57 plus 45 equals 102 minutes. Now 102 minutes equals 1 degree and 42 minutes. So our correct answer will be 14 degrees and 42 minutes, because we got 12 plus 1 plus the 1 degree over there, so it's 14 degrees 42 minutes. Now we still need to go and calculate our bearing. Now the question states, determine the present magnetic bearing from trig station 17 in G1. Okay, let's go to the map. From there to the span shaft in F5. There's, okay, there, 2, 1, 2, 3, 4, 5. Now remember what you need to do, you use your protractor, follow your steps. Draw a north-south line. Draw a line from where in 2. Place your protractor on your north-south line and read your information in a clockwise direction. Very important. And the correct bearing that you will get on the map, is 80 degrees. So the bearing that we get is 80 degrees. Now if we look at our formula, what do we need to do? We take our magnetic declination plus true bearing. In this case, it's going to be 14 degrees 42 minutes plus our true bearing is 80 degrees. So the correct answer will be 94 degrees 42 minutes west. And that's how you do magnetic bearing. Stay tuned, we're quickly going for a break. See you just in a bit.